Okay, I am good. All right, hopefully this is working. This is 3.7. This is going to be absolute value functions. This is going to be one of the pages that I grade when I grade notes because it's basically participation, and if you don't participate, it doesn't help you. Okay, so I'm going to write you the parent graph or the parent function of absolute value, and we're going to figure out how to type this in and see what it looks like. This is also called a piecewise function. Okay, it's also called a piecewise function because it has two parts to it. Okay, and when we discuss absolute value, we have the right answer and we have the left answer. And so this is going to be the same way, where this is a piecewise function where it has two parts. So pull up your Desmos calculator, if you know where that is. It should be, should be still on your computer. That's why we still have them out. And then we're going to figure out how to type this in, because this is going to be different. I might have to use this to help me. Okay, I think I see it. Something that might be helpful here. So I'm going to type in that f. F of x equals absolute value. Let's see how that works. Absolute value x. Absolute value? Okay. Okay. So I see this little graph here. It looks like straight lines, but it looks like two straight lines, right? Okay. Well, this is what I want you to do. We're going to experiment by placing numbers in different places and see what they do. So this is the first one I want you to do. And we can write f of x, we can write y, it's fine. It doesn't matter which one. Let's do, I need this again. Let's see what happens when I do this. And I don't want to show you when you do that. And let's add 5. Okay. And so we're going to get a separate graph, and this is what I want you to do on your piece of paper. Okay, so you understand what's going on. I want you to go ahead and write this y equals, so what is going to happen? So y equals, what did I say, 5?
Yeah.
I want you to tell me what happens. And there's a word that you might know, and you might not. We'll define in a second. It's called the vertex. What is the vertex? This guy right here.
Yeah.
Yeah, so that important point that, a vertex is like the edge of a rectangle, the point of a triangle. That's called a vertex. So we didn't have one with lines, but now we have a vertex. That looks like a very important point, doesn't it?
Yeah.
That point is where it splits, where it starts the right answer to the right and the left answer to the left. So I want you to do this, and I want you on your paper to tell me what has happened to the vertex based on that number. And I want you to write that down, and we'll see if you're right. I'm going to push this. What happened to it? How many did it go up? So that's what I'm going to write. I'm going to write up 5. Okay? Let's change this number. And I want you to write this down in your notes still. Let's change this number to -7. Let's see what happens when we do -7. What happened? Went down 7, right? Okay, that's not bad. So it looks like that number moves things up and down, right? Did we do something similar to lines? Okay, and I need to scroll that. Okay, that looks good. All right, let's do something different. So now we're going to do inside the absolute value, right? So let's see what happens when I do inside the absolute value. Let's do, so it's not the same thing, let's do plus 3. Let's see what happens. Do we think it's going to go up 3? Hey, I'm recording. What you? The one that I gave you? No, that's just an extra laptop. He can destroy it. Yeah. Yeah. All right, that made for a thrilling video. What happened to this thing? Move to the left 3, right? Okay, so somehow every time I put in a number, it's going to move my vertex. I like this one better than the lines because I can literally see this 1 point move, and it shifts the whole shape, doesn't it? Okay, let's try one more. Let's see what happens if we put a negative in here. Let's put negative 12. That sounds more exciting than a plus 7. Okay. What's going on with it? What happened? I got to scroll out, right? How many did it move to the right? So these are all going to be great test questions. Okay? And I'm going to let you use this calculator on it so you can experiment and get the right answer. These are great test questions. Okay? I got a few more to do. All right, no more of this. What would happen? What would happen if I did this? I don't like that. That's ugly. I'll put a little negative here. What do we think is going to happen? When we were doing the line segments, what happened when we put a negative in front of it? What was it called? So we had 3 kinds of translations, right? We had a stretch, we had a shrink, that's what they're calling them, we had a reflection, we had a translation. So all the ones we were doing are translations. What was the reflection? What did it do? Is that where we put the negative in front? So this is going to reflect, right? What does it? It looks like a reflection, doesn't it? Turned it upside down. Okay. Let's go back to our notes here, and I'm going to write you the rules. You can experiment and get the rules right, and that's how people originally came up with the rules. But I'm going to write you the formula here. So here's the formula, and I will write what everything does on the formula. So f of x, so that's a function, and that's what they want to do. And they're going to call this a x minus h plus k. This is everything that just happened, okay? And we're not going to make this super complicated. We're going to make this, we're going to just make it. So a positive is going to look like this. A negative is going to look like this. Yes? A positive h because it's negative, it basically does opposite things, just like the other one. A positive h is going to move things to the left. A negative h is going to move things to the right. A positive k is going to move things up. And a negative k is going to move things down. And by things, it's going to be our vertex. And we need to know how to find our vertex. Well, the vertex actually has a pretty easy formula here. And I'm going to make sure I give that to you correctly. And the vertex is going to be this. Vertex equals parentheses h, k. Okay? Now you got to be careful on this, on how that works, okay? It's going to be the opposite of how it looks, okay? Because that is negative h, right? So vertex is hk, but it's opposite of what it shows. So let's look at this problem and just determine where the vertex is. And then I want you to use the Desmos calculator to be sure of that that's where the vertex is. It should help you. Okay? I want you to predict where you think the vertex is. Use the Desmos calculator to type that in and find the vertex. Let's see what I typed in. I think I typed in -6. And I think I typed in +8. Okay. So it looks like the vertex is 6, 8, isn't it? Is that what it is? Did you know you could just, now that we have a point, we could just put there, it says 6, 8? Okay. How come it is 6 and not -6? Because the formula says minus, so it does the opposite, right? So that is something you have to learn, and it just is what it is. The nice thing is, this is basically the same thing we did with lines, wasn't it? Didn't we have, if it's inside the parentheses, that it affects left and right? If it's outside the parentheses, it affects up and down. So it's basically the same thing, except for this is easier. So this form is called vertex form. You don't have to do anything hard with it. You're not going to have to change vertex form into anything else. All you're going to have to do with vertex form is look at the form, graph the problem. Look at the form, tell me where the vertex is going to shift from the parent function, and the parent function is going to be the most basic. Okay? I'm going to make sure that we write this on our notes so you can see that this is right here is called vertex form. Okay. So basically, this is the conclusion of all the stuff we need to do. Why did I hit record here?